In this unit, we're going to take a little break from our geometry and we're going to work on some algebra skills to just help you keep fresh on those and remind you about those between Algebra 1 and Algebra 2, which is the next course you'll take. There aren't going to be separate guided notes. These videos will just go through and highlight actual homework problems for you, so then you'll have a worked example for each one of your homework. And then there are some more worked examples on the answer key, and obviously you'll have your mastery quizzes to practice some more. So we are going to start with homework problem number 5 in your packets. So if you can find that homework problem. Now, radicals as a word sometimes mess kids up. Another synonym would be the square root. That's square root. Or, as we worked in the similarity unit, we talked about the cube root. And then we put that index number of a 3 here. That 2 for square root is written there, but since it's the common one, we don't write it. Just like we don't write a 1 in front of a variable, but we know it's there. The key to this chapter, to this section, is that squaring and square rooting are opposite operations. Cubing and cube rooting are opposite operations. They undo each other. So when we're looking to simplify, we are looking to leave as exact answers. We are going to take out all of the perfect squares. It's kind of like reducing a fraction. We're going to take out all of the perfect squares and we're going to leave the non-perfect squares underneath the radical. So there's some shortcuts to this, and if you know your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, on down, I recommend learning them through 15 squared. It makes your life a little easier because you'll recognize perfect squares when you're factoring and you can stop sooner. If you don't, it's fine. You can factor it all the way down to prime factors and you'll get there. So the first thing we're going to do is we are going to take and we are going to factor 392. Now, 392 is an even number, so I know that 2 goes into it, and 2 will go into it 196 times. Now, if you know your math facts, 196 is a perfect square. If you don't, we're going to go ahead and say, well, it's still an even number, so 2 goes into it 98 times. And 2 goes into 98 49 times. There's another perfect square. Or I know that 49 is 7 times 7. So I've factored that. Now, I want to think about everything in terms of squares. So I want to rewrite all of my factors in terms of squares. So this 5 is going to stay out here. And I'm going to rewrite 392 in terms of these factors. And I'm going to group them as perfect squares. So 2 2's makes 2 squares. There's a random. I'll just leave that as a 2. And 2 7's makes 7 squared. I'm going to do the same thing with these exponents on these variables. X cubed is x squared times x. There's still 3 of them. Y squared is a perfect square. Z to the 4th, I'm going to write that as z squared times z squared. So I haven't done any math except to factor and break everything down into perfect squares. And these are the ones that I'm going to focus on. So what's going to happen is I'm going to go through, and this operation between this 5 and the radical is multiplication. It's like a coefficient in front of a variable. It's multiplication. Anything that comes out from underneath the radical gets multiplied. So I'm going to have my 5 and I'm going to leave a blank and I'm going to have my radical. So I'm going to look at each of these separate. So basically I'm going to say the square root of 2 squared. That's this part right here. Well, that's going to cancel and a 2 can come out. I can do that operation. But this 2, I can't take the square root of, so it stays under the radical. The square root of 7 squared is 7, so that comes out. The square root of x squared is x, so that comes out. But this x doesn't have a square root, so it stays under. Square root of y squared is y. Square root of z squared is z. Square root of z squared is z. So then I just have to clean this all up. All of this gets multiplied. So I have 70x, y, z squared. This is my leftover. And so that's what I leave as my exact answer. I've taken all of the perfect squares out, and I've left that as my exact answer.